Good morning, everyone. Today we are going to discuss about tropical cyclone. In our earlier video, we have discussed about the cyclone and anticyclone and different types of cyclones. Okay, in this tutorial, we are going to discuss about tropical cyclone. First of all, what is exactly is a tropical cyclone? Tropical cyclone is a large non-frontal low pressure system that forms over tropical or subtropical waters. Okay, tropical cyclone is formed over a tropical or subtropical regions. It is defined by organized thunderstorm activity, a persistent group of thunderstorms with heavy rains and strong wind gusts. Closed cyclonic circulation, a distinct rotating wind system. This rotation is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere, driven by the Coriolis force, and is central eye, a claim region at the center of the storm. Okay, this is the central eye or claim region. Anti-clockwise rotation in the northern hemisphere and clockwise in the southern hemisphere, and this is the closed cyclonic circulation. Okay, and this is circulation part like this. Now, there are some ingredients for a superstorm, that is cyclone. A tropical cyclone cannot form without a precise combination of atmospheric and oceanic conditions. The absence of any one of these can prevent an engine from starting. Okay, all are most necessary conditions for creating a cyclone in tropical and subtropical regions. Okay, there is first of all, the warm ocean fuel, large sea surface. There must be large sea surface with a temperature higher than 27 degrees Celsius. Okay, temperature must be higher than 27 degrees Celsius. Then sufficient spin, the presence of the Coriolis force to create a cyclonic vortex, Coriolis force. Then stable atmosphere, small variations in vertical wind speed, low wind shear, the low pressure needed, a starting point. A pre-existing weak low pressure area or low level disturbance, then an exhausted vent, upper level divergence to pump air away from the storm center. Okay, these are some basic prerequisites for creating a formation of a cyclone. Okay, now the immense energy of a cyclone is powered by the release of latent heat of condensation. Okay, now evaporation, ocean water warmer than 27 degrees Celsius provides abundant moisture to the air through evaporation. This warm moisture is the initial fuel. Then condensation. As this air rises, it cools and the water vapor condenses back into liquid droplets, forming massive cumulonimbus clouds. Okay, first of all, evaporation. This is the portion of evaporation. The water vapor, ocean water warm, and moisture to the air through evaporation. This is the process, and creates clouds, cumulonimbus clouds during the process of condensation. Then energy release. This act of condensation releases enormous amounts of stored energy, latent heat, that is called as latent heat, into the atmosphere. This heat makes the air lighter, causing it to rise further and strengthening the storm's updraft, which in turn draws in more moisture from the ocean. This is a powerful and self-sustaining feedback loop. Okay, this is the evaporation, then self-sustaining feedback loop. This is happen again and again. It's a continuous cycle, and latent heat release energy and strengthening updraft. Now the cloud is formed, cumulonimbus clouds, due to the process of condensation. Okay, these are three basics: process, evaporation, condensation, and energy release. Now the ignition sequence from disturbance to vortex. Okay, first of all, disturbance. It begins with a pre-existing disturbance, often a low pressure trough or an easterly wave within the intertropical convergence zones (ITCZ), where multiple thunderstorms merge. Okay, first of all, it must need a disturbance in weather systems. Then intensification, that is low pressure. As warm moist air is drawn into the low pressure system, condensation releases latent heat. This hits the air, causing pressure at the center to drop further. Then rotation, that is Coriolis effect. Air rushing towards the low pressure center is deflected by the Coriolis force, initiating a cyclonic spin. For a vortex to form, the Coriolis force must be significant, typically found above 5 degree latitude in both hemispheres. Then organization, the storm becomes a self-sustaining heat engine. A central eye begins to form as the vortex becomes more organized and intense. Okay, these are ignition sequence from disturbance to vortex of a cyclone: disturbance, intensification, low pressure, rotation, Coriolis effect, and organization of forming the cyclone. Okay, why a stable structure and a clear exhaust are crucial. Okay, low wind shear is essential. Why? Vertical wind shear is the difference in wind speed at different altitudes. Okay, high wind shear disturb the storm vertical structure, tilting the column of rising air and preventing the heat engine from stacking up efficiently. It effectively tears the developing storm apart. Okay, then upper tropospheric divergence for the storm to maintain its low pressure at the surface, the air rising in the core must be efficiently removed at the top. Like this. It is outward flowing air, okay, outward flowing air at the high altitude. High altitude means 7 km from the earth's surface. And from the high altitude, divergence acts like an exhaust wave hand, allowing more warm, moist air to be continuously drawn in at the bottom. Okay, this is the process. This is the process. Like this. Again, like this. Inflow, divergence, exhaust, and 7 km. This is the height of a cyclone. Now inside the engine, okay, this is the engine, the anatomy of a meteocyclone. The basics characteristics are found, we can found in the engine of a cyclone. The first of all, the eye wall. This is the eye wall portion. The most violent zone with highest wind speed and heaviest rainfall. Okay, it's characterized by highest wind speed and heaviest rainfall. Then the eye, sinking air is a clear and warm core. This is a clear and warm core. Then outflow canopy. This is the outflow canopy, this portion. High altitude exhaust of cold, dry air essential for maintaining the storm. Then spiral rain bands. These are spiral rain bands. Clouds. Organized bands of thunderstorms. Okay, organized bands of thunderstorms that feed moisture into the core. Okay, the paradoxical claim, the closer look at the eye. Okay, this is the eye. Okay, size varies from 8 km to over 200 km in diameter, but typically 30 to 60 km. Okay, then conditions: an area of light winds, little to no precipitation, and sometimes clear skies. Like this. Pressure, the region of lowest surface pressure in the storm. Okay, the region of the lowest surface pressure in the storm. Okay, temperature, lowest surface pressure. Temperature, the warmest part of the storm. At upper levels, the air is warmed by compressional heating. As it slowly sinks, the eye can be 10 degrees Celsius warmer than its surrounding at an altitude of 12 km. Okay, this is the some characteristics of eye. Then the eye well. This is the eye well portion. The eye well is a circular ring of deep convection surrounding the eye. It is the powerhouse of the cyclone. Highest wind speed, the maximum sustained winds of the cyclone are found here. Intense updraft. It features a net upward flow of air driven by strong updrafts that carry warm, moist air to the top of the troposphere. Then formation rule: convection in the spiral bands converges towards the center. As the air subsides and warms on the inside of these bands, a sharp pressure drop occurs and increasing wind speed and eventually forming the encycling eye wall. Then the vertical blueprint: layer 1, layer 2, layer 3. Layer 1 is the inflow layer, 0 to 3 km, and layer 2 the cyclonic core, 3 to 7 km, and layer 3 the outflow layer above 7 km. First of all, layer 3, the outflow layer above 7 km. This is the outflow layer. This is the outflow layer. The engine's exhaust air that has risen to the core and lost its moisture diverges outwards at the top, often in an anticyclone pattern. This outflow at altitudes around 12 km is crucial for maintaining the low pressure at the surface. Then layer 2, this is the layer 2, the cyclonic core, 3 to 7 km, the main combustion chamber. This layer contains the primary storm activity where rising air, intense convection, and latent heat release occurs. Then layer 1, the inflow layer. This is the layer. This is the engine's intake. Warm, moist air is drawn in from the ocean surface towards the low pressure center, and it's prevail in 0 to 3 km above the sea surface. Okay, where does this engines from? Okay, the regions. Why do they form predominantly on the western margins of oceans? Western margins of oceans, like this. Warm currents, dread winds push warm surface water from east to west, causing a thick layer of water less than 27 degrees Celsius to accumulate in the western part of tropical oceans. This provides the necessary heat and moisture. Then cold currents, eastern ocean margins are typically dominated by cold currents which inhibit cyclone formation. That's why there are no dominant cyclone in the eastern coast of the part of the oceans. The El Nino exception, during strong El Nino, yes, warm water accumulates in the eastern Pacific, leading to the formation of strong hurricanes there. Okay, these are some regions of cyclone. Now the steering winds. Okay, the path of a tropical cyclone is not random. It is primarily shared by large-scale horizontal atmospheric flows, much like a cork in a river. Okay, step 1, westward movement, like this easterly trade wind. Westward movement, initially in the tropics, the easterly trade winds shear the cyclone from east to west. Then step 2, poleward turn, like this, attitude around 20° latitude. The influence of the Coriolis force and other systems cause the storm to turn up towards the pole. Then step 3 is recurved eastward. Again, it moved towards the east. Around 25° to 30° latitude, the storm enters the domain of the mid latitude westerlies, which is steer it back towards the east direction. Okay, this is the direction of a cyclone path. Then navigating atmospheric barriers and corridors. Okay, subtropical ridges. These strong high pressure systems, example the Bermuda Azores high at these atmospheric walls. Cyclones are forced to move along these boundaries, deflecting them. Then westerly troughs of low pressure in the mid latitudes create corridors that can attract cyclones, pulling them poleward and accelerating their northeastward recurvature. Then Fujiwara effect, when two cyclones get close to each other, they begin to rotate around a shared central point. This interaction can significantly alter the path and speed of both storms. Okay, this is known as Fujiwara effect. Okay, now the shutdowning point of a cyclone. The tropical cyclone power is immense but infinite. It is not infinite, it is finite. It weakens and dissipates when it accesses to the core condition that sustain it is removed. Loss of moisture supply. The primary reason for dissipation, when a cyclone moves over land, it is connection to the warm ocean water. Its main fuel source is cut off. Okay, then cooler ocean water moving into higher latitudes, typically beyond 30°. The storm encounters cooler sea surface temperatures and that are insufficient to fuel the heat engine. Then increased wind shear at these higher latitudes. The storm often encounters the stronger vertical wind shear associated with the westerlies, which disrupts its vertical structure and tears it apart. Okay, this is the peak intensity, then landfall, then dissipation. Okay, like this. Okay, there are various names of these cyclones in the eastern Indian Ocean, eastern Pacific, hurricanes in this portion, cyclones in Indian Ocean, Willy Lake Australia, typhoon in South China Sea or Japan portion. Okay, so they are called by different names. There were formidable nacelle engine driving them as the same, powered by the heat of the tropical oceans. Okay, that's all for today. In this class, we have learned about cyclones, its formation processes, then characteristics and the stages of formation and different names. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.